Okay, in this example of using the LupinPet tool, we'll examine detecting 404 errors. So a lot of times in web applications, some of the links are missing. This will generate 404 or missing resource errors. In a distributed application, or where you're expecting remote users who may be experiencing fairly high network latency, these 404 errors can usually impact performance by requiring one network turn to basically show that that resource is not available. Where you've got a web page with a lot of these 404 errors on it, then this could have a substantial impact on the observed performance, especially for very high latency conditions, such as you get across, say, a cellular network, or even global connections. For example, connections from US to somewhere like Australia is typically in the 200 millisecond round trip time, and that's really just driven by the speed of light and physical constants rather than being anything you can improve. So being able to detect these 404 errors and remove them from an application before deployment can improve the experience for a lot of users. So let's have a look at a test to see these 404 errors and how they're shown in the LupinPet tool. So I'm going to start off. I'm going to start a new simple network capture. I'm going to call the trace file. I'm going to capture 11404. I'm going to use the IP address of the Lupin website, because I've got a special page set up there with a lot of that generates a lot of 404 errors, and then I'm going to filter on port 80 because I don't want to see all the traffic that might be going up there. I'm also going to open up a web browser here, and you see I've got a link on my tutorial page to the missing 404 error page. So let's start the trace, go back to the browser, go into that page. You'll actually see I've got a whole bunch of links to images that don't exist, so I'm actually getting 99 requests for missing content. Okay, I can stop my trace, and you see I've now got a trace file with the results of that particular transaction in it. If I click on that, I see that the total duration for the transaction was 3.8 seconds. Isn't too bad locally, but you'll find if I ran the same transaction across higher latency links, then the impact of retrieving each one of those each one of those images and not finding it will impact the time of the transaction substantially. First, looking at conversations, I can do a port level view. Interesting thing here is you see a lot of different ports being used on the client. This is because the client has the ability to retrieve each one of the images it's trying to collect on a different port number. So that's very efficient, and you can sort of see that in the overlapping and Gantt chart here of the transaction. So it's getting something like 6 images at once here. So that level of parallelism doesn't improve the performance of this application, but again, because you've got so many 404 errors, it's still really impacting the performance of the page. So the page here probably should take something like 4.8 seconds, half a second to complete, because of all these 404s cascading down here. In this case, this page is extended to taking close to 4 seconds to complete. We also look in the turn details. It's going to show us a similar sort of details in the Gantt chart. You can see each request and response. The request is in red and the response is in blue for each of the items it's trying to retrieve on the page. The turn information is probably a lot more useful because it's going to show you in more detail what the actual request was, and you can see it's a request for a specific image and what the response was from the server. So we're seeing a response of, let me just expand this a little bit, of 404 errors, as you'd kind of expect, and it's cascading all the way through here. The other place that may be interesting to see what's happening here is in the time series graph, and you see there's a lot of activity over that full 3 seconds period while it's getting trying to get 6 of those images at once, but because it takes a certain amount of time to request and respond to each of those 6, it gets extended over 3.5 seconds to get all the 404 information. And I did one more trace earlier of the exact same page, but showing you for say a user in somewhere like Australia retrieving the same information. So I used a network emulator to set up a 1.5 megabits per second link and a 250 millisecond latency. And now when we look at the time series graph, we see it's extended to 14 seconds. If we look at the turn details, it's the same sort of pattern of cascading requests and reply, but the time to do each one of those requests and reply has been extended by the network latency, and you can sort of see that in the back end duration here, that it's taking 351 milliseconds, at least from the client point of view, in back end time. So we know with the 250 millisecond delay that most of that back end duration is driven by the network latency.